Good afternoon, everyone. Welcome to i²-Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at one very important topic in mathematics, further mathematics, and the topic also called across physics, equations of motion. Yes, equations of motions. So under equations of motion, we are going to be looking at how to derive all the equations of motion. Now, first of all, we are going to start by looking at the definition of acceleration. Now, acceleration can be defined as the rate of change of velocity with respect to time, with respect to time. Full stop. Now, A, acceleration, is v minus u all over t. Okay? And of course, we can also express this as v minus u all over t2 minus t1. Now, in this case, our v, where v is the final velocity. Yes, v is the final velocity. U is the initial. Yes, u is the initial velocity, and t is the time. Yes, t is the time. Now, if A is equal to v minus u all over t. Now, remember, this A is the same thing as A all over 1. Now, when you cross multiply, yes, so A times t, what it as AT will be equal to v minus u, Yes, because A times t is AT, and v minus u times 1 is v minus u. So it therefore means that AT plus u is equal to v. So it means our velocity is AT, that's AT plus u, or v is equal to u plus AT. Now let's call this equation 1. Now before we move further, let's define velocity. Now velocity can be defined as the rate of change of displacements with respect to time. Yes. So it means velocity is actually a vector quantity. Yes, because it's actually the rate of change of displacement. And we all know that displacement is distance moved in a specified direction. Now we said the value of our v is u plus AT, and we said this is equation 1. Yes, v plus AT, u plus AT rather. Now let's look at mean velocity. Now this mean velocity, also represented as v mean, is equal to, we have u plus v all over 2. Yes, u plus v all over 2. Remember we said our u is the initial velocity and v is the final velocity. So the mean velocity is initial velocity plus final velocity all over 2. Now, displacement, distance. Now, let's call this distance. Distance is mean velocity times time. Yes, distance is mean velocity times time. Or let's call it displacement. Displacement displacement is mean velocity times time. Now, we all know the difference between distance and displacement. When you say distance, distance is a scalar quantity, while displacement is a vector quantity. Because displacement is actually distance traveled or moved in a specified direction. Now, in this case, displacement is always designated by letter S. Yes, we use X to represent distance, displacement. So now, for the mean velocity, we said mean velocity times time. So it means here, this mean velocity is u plus v all over 2. Then here we have times time. But recall that our v is equal to u plus at. Yes, v is equal to u plus at. So it therefore means that s will be equal to u, then we have our u plus the value of v is u plus 80, everything here over 2. Yes, because here we said displacement is initial velocity plus final velocity all over 2 times t. That's the mean velocity times time. Now, in this case, our x here will be equal to u plus u is 2u. Then here we have we have t here. Yes, that's this time here. We have t there. So we have 2u plus 80 all over 2. Then here we have times t. So it therefore means that s will be equal to 2u all over 2 plus 80 all over 2. Then here we have times t. So it means our x will be equal to, these 2 will go with this 2. So we have u plus 80 all over 2 times t. So it means our x will be equal to u times t is ut plus 80 times t over 2. That would be half a t squared. So this is the second equation of motion. So x is equal to ut plus half a t squared. Now let's look at this again. Let's look at this. Now let's look at our v. Recall, v is equal to u plus 80. Yes, v is equal to u plus 80. So if v is equal to u plus 80, now it means our v minus u is equal to 80, and the value of our t will be equal to v minus u all over a. Now let's look at this. The value of our t will be v minus u all over a. Now let's put this now. Let's put or substitute. Yes, or substitute t is equal to v minus u all over a into equation 2. Yes, into equation 2. Now into this equation. So it means the value of x now will be equal to, we have ut. Yes. So here we have u times the value of t. Remember, the value of t now is v minus u all over a. Then here we have plus. So here we have plus half. We have half a. Then the value of t is v minus u all over a. Now remember, we have square here. So it means this will be all squared. So it means that our x now will be equal to uv minus u squared, because u times uv is uv. U times minus u is minus u squared. Then here we have plus. Here we have all over a. That is this a. Then plus. Here we have half in bracket a. Then this v minus u all squared. Let's still bring it there. V minus u all squared all over, here we have a, we have all over a squared. Yes, all over a squared. Now because what we have here is v minus u all over a all squared. So now I'm separating this now. So v minus u squared, and here we have a squared. Now, it therefore means that the value of our x now will be equal to, we have uv minus u square all over a. Then here we have plus half in brackets. Now we have a here. So here we have a. Then here we have v minus u all squared. That will be v square minus v minus u squared. That will be v squared minus 2 times v times u. That's 2 uv. Then here we have plus u squared. So here we have u squared all over a squared. Yes, all over a squared. So it means the value of our x now will be equal to uv minus u squared all over a. Then here we have plus. Now look at this. This a will cancel one, and this a here will be left with a. So it means we have v squared minus 2uv plus u squared all over. Now 2 times a is 2a. Now let's begin. The LCM of a and 2a. The LCM of a and 2a is 2a. Now a into 2a is a. Yes, and a times the numerator. It will be a in brackets uv minus u square plus 2a into 2a is 1. 1 times this, it becomes 1 in brackets v square minus 2uv plus u square. Now it means the value of our x now will be equal to, when you multiply this out, we have auv minus au square. Then here we have plus v square minus 2uv. Then here we have plus u square. Now everything here all over 2a. Yes, all over 2a. Now please, sorry, I take it again. Sorry, a into 2a is 2. Yes, a into 2a is 2, not a. Yes, a into 2a is 2. So 2 times this. So it means our x will be equal to, we have 2uv minus 2u square plus v square minus 2uv plus u square all over 2a. Yes, all over 2a. So it means the value of x now will be equal to, this 2uv will go with this 2uv. Yes, 2uv will go 2uv. So here we have minus 2u squared plus u squared. That will give us v square. Yes, that is v square. Minus 2u squared plus u squared. That will be minus u squared all over 2a. Yes, all over 2a. So it therefore means that, yes, let me minimize the space. So it therefore means that s is equal to, we have v square minus u square all over 2a. Now when you cross multiply, now let's cross multiply. So cross multiplying, this is all over 1. So when you cross multiply, you have 2a times this. That will give us 2as is equal to v square minus u square. Because v square minus u square times 1 will give you v square minus u square. So it therefore means that 2as, when you bring this minus u square to the other side, it becomes plus u square. And that will give us v square. So it means our v square is equal to u square plus 2ax. Now this is equation 3. Yes, that's equation 3. Now we have seen equation 1, we have seen equation 2, and of course we have also seen equation 3. Yes, we have seen 1, 2, and 3. Yes, 1, 2, and 3. Now what we are saying here is this. What we are saying here is this, that our v is equal to u plus at. This is equation 1. We have s is equal to ut plus half at squared. This is equation 2. We also have our v square is equal to u square plus 2ax, which is equation 3. Now this is for a body that is accelerating. Yes, because we said acceleration is the rate of change of velocity with respect to time. So if this body is decelerating, yes, let me put it here, acceleration. Yes, acceleration. Now, if the body is decelerating, yes, because deceleration is the negative aspect of acceleration. Yes, deceleration is negative acceleration. So it means here our v will be equal to u minus at equation 1. Our x will be equal to ut minus half at squared equation 2. And our v square will be equal to u square minus 2ax equation 3. Now, this is when the body is actually decelerating, when the body is coming to rest. Now, let me put it here. Yes, coming to rest. Yes, while here, the body actually starts from rest. Yes, so now we want to see how to use calculus to derive the whole of these equations of motion. And that is basically what this class is actually designed for. Yes, using calculus to derive the equations of motion. Now, let's look at this. Yes, let's look at this. Now, first of all, we define acceleration as the rate of change of velocity with respect to time. Yes, the rate of change of velocity with respect to time. So it means acceleration. Now let me put it here. Derivation of the equations of motion using calculus. Yes, using calculus. Now, A is changing v all over changing t. Yes, A is changing velocity all over change in time. That's the rate of change of velocity with respect to time. Now, if A is changing v all over changing t, now let's do it. This is A all over 1. Now, let's cross multiply. Now, when you cross multiply, it means here we have the v. The v times 1 is the v. And that will give us a times the t. That will be a the t. So we have the v, we have a the t. Now, let's do that. Integrating both sides. Now, when you integrate both sides, here we have integral the v will be equal to integral a dt. Now, remember this a here is constant because we are differentiating with respect to what? To the t. So it means I can have it like this. Integral the v will be equal to a integral dt. So now when you integrate the v, it gives you v. Yes. When you integrate the derivative of velocity, yes, it gives you the velocity. So now, when you integrate the t, this will give us a. When you integrate the t, it gives you t. Then here we have plus constant. Yes, we have plus constant. So it therefore means that our v is equal to at plus c. Now let's call this equation 1. Yes, let's call this equation 1. At t is equal to 0. Now, at t is equal to 0. Now, if t is equal to 0, it means the body is at rest. So now, at t is equal to 0, the velocity will be the same thing as the initial velocity. Yes, the velocity will be the same thing as the initial velocity. So it means that here, we have our v is equal to a in bracket 0, then we have plus c. A in bracket 0 plus c. So it means our v will be equal to 0 plus c. So it means v now will be equal to c. But recall, at t is equal to 0, v is equal to u. So it means that here, our v now will be equal to at, we have at plus c. Yes, I remember here we said v is equal to c and v is equal to u at time 0. So it means here our v will be equal to at plus u, which is the same thing as saying v is equal to u plus at. That's equation 1. Yes, that's equation 1. Now let's do the distance. Now remember we said our velocity is change in displacement all over change in time. Yes, velocity is change in displacement all over change in time. Okay, so the rate of change of displacement with respect to time is what is referred to as velocity. So it means in this case, now let's cross multiply. Let's cross multiply. Now when you cross multiply, we have, okay, now from v is equal to the x all over the t. Now the next step is to cross multiply. So cross multiplying, we have v the t is equal to the x. Yes, which is the same as saying the s is equal to v the t. Now at this point, remember we said the value of our v is u plus at. So it therefore means that here we have the x to be equal to u plus at, and here we have the t. Okay, the t. Now integrating both sides, integrating both sides. So it means here we are integrating both the left hand side and of course the right hand side. So here we have integral the x will be equal to integral u plus at, and here we have the t. Yes, u plus at the t. So it means at this point, now remember the initial velocity here is equal to 0. While here we have the final velocity. Yes, so here we have the final velocity and here we have the initial velocity. So the final velocity here actually ends at time t. Yes, why it actually starts with 0? Because at u is equal to 0, here the value of our t is equal to 0. So when you integrate this dx, we have x. Yes, when you integrate change in x, we have x. Now when you integrate the whole of this, we have ut plus at square all over 2. Then here we have plus c. Then 0t. Yes, 0t. So at this point, the value of our x now will be equal to, the first thing is to substitute t here. Now we have ut plus at square all over 2 plus c, then minus, now you substitute 0 anywhere you see t. So if you put 0 here, you have 0t, sorry, u0 plus a0 square all over 2, then we have plus c. Okay, so here the value of our x should be equal to ut plus half at square plus c. 0 times u is 0, so we have minus 0. Here we have another 0, minus 0. Then here we have c, minus c. It means the value of x should be equal to ut plus half at squared. Now c minus c is gone. Now 0 minus 0 is gone. So here this is our equation 2. Yes. Now equation 1. Our equation 1, we said v is equal to u plus at. That's equation 1. And now we have our equation 2. The equation 2 is x is equal to ut plus half at squared. That's equation 2. Now remember from our definition of acceleration, we said acceleration is the rate of change of velocity moved with time. It therefore means that our a, acceleration, is the v all over the t. Yes, acceleration is the v all over the t. Now at this point, let's look at this. It means this our a is the same as the v all over the s times the s all over the t. Yes, yes, a is equal to the v all over the x times the x all over the t. And remember the x all over the t is velocity. Yes, because we said velocity is change in displacement all over change in time. And we all know that our x here is displacement. So it means a will be equal to the v all over the s times v. Yes, because velocity is change in displacement all over change in time. So it means what we have here now will be a is equal to the v all over the x. Yes, the v all over the x. So at this point, sorry, the s. So at this point, Now let's cross multiply. Yes, let's cross multiply. Now when you cross multiply, because this is all over 1, what you have here will be a the s will be equal to v the v. Yes, a the x will be equal to v the v. Now integrating both sides. Integrating both sides. Now when you integrate both sides, your integral a the x will be equal to integral v the v. So when you integrate a, now let's look at this now. This is acceleration. Yes. And this is change in displacement. Is equal to the integral of v the v. Now at this point, when you integrate this, because now when the body starts from rest, here, when you start from rest, the initial velocity we said is equal to 0. Yes, and at this point, our x is also equal to 0. Then here, we have time t. Okay, the time here is 0 as well. Then here we have the final time to be t. So it means at this point, what we have here will be equal to, when you integrate a dx, we have as. Yes, we have as. Then when you integrate v, we have v squared. We have v squared all over 2. Then here we have plus c. Okay, v squared all over 2 plus c. So it therefore means that our ax integral a dx. Now since here we have this starting from the initial velocity, we have u, and here we have v. Okay, we have u, then v, then of course v the v. So it means here our ax will be equal to, here we have v squared all over 2 plus c. And now this will be equal to, this is equivalent to, now for the value of v, when you put this v there, we have v squared all over 2 minus, now you put u there, we have u squared all over 2. Now the c will go. Yes, the c will go. So it therefore means that here, yes, it therefore means that here, what we'll have there will be v squared minus u squared all over 2. Yes, v squared minus u squared all over 2. Now let me explain this clearly. Now what we're trying to say here is that the body starts from the initial velocity u, and v here is the final velocity. Now when we integrate, we said when you integrate the v, and here we have the final velocity, here we have the initial velocity. That will give us v squared all over 2 plus c. Then here we have u and v. So at this point, what we have here now will be, when you put v here, we have v squared all over 2, v squared all over 2 plus c, then minus. Now you put the value of u here. You have u squared all over 2 plus c. So at this point, this will be v squared all over 2 plus c minus u squared all over 2 minus c. So at this point, this c will go with this c. So you'll be left with v squared all over 2 minus u squared all over 2. So here, let's look at the LCM. The LCM of 2 and 2 is 2. Now 2 into 2 is 1. And 1 times v squared is v squared. So here we have minus 2 into 2 is 1. 1 times u squared is u squared. So it means change in v, the v, where we have v as the upper limit here, then we have u here. It will be v squared minus u squared all over 2. Yes, all over 2. So it therefore means that here, what we have here will be, now at the left hand side we have ax. Yes, we have ax, because we say when you integrate a with respect to the x, it gives ax. So at this point, our ax will be equal to, here we have the right hand side, v squared minus u squared all over 2. Okay, all over 2. So now let's multiply through by 2. Yes, multiplying through by 2. So when you multiply through by 2, it means here we have 2 times as is equal to 2 times, we have v squared minus u squared all over 2. Now, those 2 will cancel those 2. You'll be left with 2as is equal to v squared minus u squared. Now, to get those v squared, when you take this minus u squared to the other side, it becomes u squared plus 2as is equal to v squared. So it therefore means that our v squared is equal to u squared plus 2ax. Now, this is equation 3. Now, we have seen equation 1. Yes, we have seen equation 1, we have seen equation 2, and of course, equation 3. Now, let's figure equation 1. Now, let's bring it up. Equation 1, equation 2, and equation 3. So here, we have equation 1. Yes, we have v is equal to u plus at as our equation 1. Now, equation 2, we have s is equal to ut plus half at squared. That's equation 2. Now, equation 3, we have v squared is equal to u squared plus 2ax. Yes, that's equation 3. Now, this is actually when the body starts from rest. Yes, when the body is accelerating. Yes, if the body is coming to rest, it means all the positive sign will change to negative because deceleration is negative acceleration. Now, at this point, we are going to be looking at how to use this to solve a problem. Yes, we're going to be looking at how to use it to solve a problem. Now, let's look at this. There's the problem. Example on the board. Yes, here's an example on the board. Yes. Now, example 1. Here, a test drone lifts off vertically from rest at ground level. Yes, at ground level. Because it thrust fits as fuel burns, its upward acceleration varies with time as a of t is equal to 4 minus 0.8 t. Yes, 4 minus 0.8 t meter per second square. We all know that the unit for measuring acceleration is meter per second square because we said acceleration is actually the rate of change of velocity move with time. And we know that velocity is the rate of change of displacement move with time. So it means acceleration is the double rate of change of displacement. Yes, when you differentiate displacement twice, it gives you acceleration. So now let's figure this now. Solution. Yes, so they gave us the value of a of t. That a of t is equal to 4 minus 0.8 t. Then here we have meter per second square as the unit. Okay. Now the first question there, we're asked to find the velocity vt and height st for all values of t, that's the time, greater than or equal to 0. Now let's figure this again. Now remember we said acceleration. Yes, acceleration is change in velocity all over change in time. Yes, acceleration is change in velocity all over change in time. It therefore means that here the velocity will be integral a dt. Now when you integrate acceleration, it gives you velocity because now we said when you differentiate velocity, it gives acceleration. So when you integrate velocity, it actually gives, when you integrate acceleration, it gives velocity. It means the value of our v here will be equal to integral. Now the value of a is 4 minus 0.8 t. Now with respect to t, that's the t. It means our v here will be equal to, when you integrate 4, you have 4t minus, when you integrate 0.8 t, we have 0.8 t squared all over 2. Then we have plus c. Okay, plus c. So it means here our v will be equal to 4t minus 0.4 t squared plus t. Now remember, the body actually lifts up vertically from rest. Please take note of this word, from rest. Yes, from rest. Since the body actually starts from rest, yes, since the body actually starts from rest, it means the whole of this now will be our v will be equal to, we have integral 4 minus 0.8 t with respect to the t. Now it starts from where? So that's 0, then n the time t. Okay, so at this point, our v, now remember we integrated the value of our a, and we got the whole of this. It means what we have here now will be 4t. We have 4t minus 0.4 t squared plus c. Then here we have t 0. Now this is actually a definite integral. So now the first step here is to substitute the value of t here. So now it gives us 4. T is t. So here we have t minus 0.4 t squared plus c. Yes, we are putting, anywhere you see t here, you are putting this t. Yes, so since t is t, it will still retain its value. Then here we have minus. Now the next is to put 0. Anywhere you see t now, you are putting 0. So you have 4 in bracket 0 minus 0.4. We have 0 squared plus c. Then you close the bracket. So here it means our v now will be equal to, we have 4t minus 0.4 t squared plus c minus. Now we all know 4 times 0 is 0. So opening this bracket, this becomes 0 minus, this becomes another 0, because 0 squared is 0 times this will give you 0. We have 0, then minus plus is minus, so we have minus c. It means our v now will be equal to, we have 4t minus 0.4 t squared. Now c minus c will go with this. This c will go with this c, and this is 0 minus 0. So it means our v will be equal to, yes, our v will be equal to 4t minus 0.4 t squared. Now this is the velocity. Yes, that's the velocity, because we're asked to find the velocity vt and height st. So now let's include t there. It means the velocity at time t will be equal to 4t minus 0.4 t squared. So that is the velocity at time t. Now let's see the height. Yes, let's see the height. Okay, yes, it's height. Let's see the height. Now the height, when you're dealing with a body that is going upward or coming downward, you call it height. But when the body is on the ground, you refer to it as distance. So it means this x here, yes, the x there is height, okay, because we are dealing with the body going upward. Now at this point, let's look at, remember we said velocity is change in displacement all over change in time. Yes, we say velocity is the rate of change of displacement with respect to time. That is change in s all over change in t. So at this point, if velocity is this, it means that the value of our x will be integral v dt. Yes, remember we said integration is actually the reverse aspect of differentiation. It therefore means that when you differentiate displacement with respect to time, it gives velocity. So it means when you integrate velocity, it gives a distance. Yes, it gives distance. So at this point, we have s will be equal to, now we have the value of our v. Yes, we have the value of our vt. Now look at the value of vt. So it means the value of v now will be, we have 4t minus 0.4 t squared. Now with respect to the t. Yes, this is the t. With respect to the t. So it means the value of our x now will be equal to, when you integrate this, we have 4t squared, yes, all over 2 minus 0.4 t raised to the power of 3. Yes, raised to the power of 3. When you add one here, it becomes 3. Then all over 3. Then we have plus c. But remember, the c will go just like this case. Yes, because the body actually starts from rest. So here, it means the value of our x will be equal to, we have 2t squared minus 0.4 all over 3, then t raised to the power of 3. Now I want to change this 0.4 to fraction. Yes, I want to change the 0.4 to fraction. So it means here we have 0.4 divided by 3. Let's multiply both numerator and denominator by 10. It means that will give us 0.4 times 10. That will give us 4. 3 times 10. That will give us 30. So 4 here, 2 here is 2. And 2 into 30 is 15. So it means here our s of t will be equal to 2t squared minus 2 all over 15 t raised to the power of 3. Yes, that's the value of our st. Okay, that's our question number 1. Find the velocity vt and height st for all t is greater than or equal to. So this is the distance, the height at time t. Yes, the height at time t, the displacement at time t. So now, let's look at question number 2. Now we're asked to determine the time of maximum speed. Yes, maximum speed. Now, at maximum speed, yes, the v all over the t will be equal to 0. Yes, at maximum speed, change in velocity all over change in time will be equal to 0. And now let's look at our velocity. Remember our v of t is equal to 40 minus 0.4 t squared. Now let's look at change in v all over change in t. Yes, change in v all over change in t will be equal to, here we have 4. When you differentiate 4t, it gives you 4. Then minus, now this times is that 0.8t. Now 0.8t, because 2 times 0.4 is 0.8. And remember we said at maximum speed, it is actually equal to 0. So it means 4 minus 0.8t is equal to 0. Now it means 4 will be equal to 0.8t. Now to get the value of t, we divide through by 0.8. So here we have 4 all over 0.8 is equal to 0.8t all over 0.8. So at this point, let's see the value of 4 divided by 0.8. Okay, 4 divided by 0.8. 4 divided by 0.8. Let's times this by 10 and this by 10. Now give me 40 all over 8. Yes, because 4 times 10 is 40. 0.8 times 10 is 8. And 40 divided. So here we have, here we have 40 all over 8 is equal to, now remember this will go with this. This will go with this. So it's equal to t. It means the value of our t will be equal to 40 divided by 8 is 5. So we have 5 seconds. Yes, 5 seconds. Now the question is, determine the time of the maximum speed and the value of the maximum speed. And the value of the maximum speed. Now that we have actually determined the time of the maximum speed, now let's see the maximum speed. Now the maximum speed, it will be v of 5. Yes, because the time that we actually got the maximum speed at time t is equal to 5 seconds. So the maximum speed will be v of 5. So that will be 4 in brackets. The value of t now is 5 minus 0.4. The value of t is 5. So we have 5 squared. So it means our v of 5 will be equal to, here we have 20 minus 0.4 times, this is 25. Okay, so this is the same v of 5 will be equal to 20 minus, it is 4 all over 10 times 25. Yes, times 25, because 0.4 is the same thing as 4 all over 10 times 25. So v of 5 will be equal to 20 minus, now 4 times 25 is 100. We have 100 all over 10. Yes, 4 times 25 is 100. So we have 100 over 10. So it means our v of 5 will be equal to 20 minus 100 divided by 10 is 10. So 20 minus 10 is equal to 10. And we all know that the unit for measuring velocity is meter per seconds. It's meter per seconds. So it means here our v of 5 is equal to 10 meters per second. Now the next line of action here is we're asked to find the time and height at the peak of the flight. Yes, at the peak of the flight. At the peak of the flight. Yes, at the peak of the flight. So now we are here. Yes, question number 3. They said determine, find the time and height at the peak of the flight. Now at the peak of the flight, the velocity is equal to 0 meter per second. Yes, at the peak of the flight, the velocity is equal to 0 meter per second. So it means our v is equal to 0 meter per second at the peak of the flight. Okay, at the peak of the flight. And remember we said our s, yes, that's the height of the flight. Our head s is equal to 2t squared. We have 2t squared minus, we have 2 all over 15, then t raised to the power of 3. Yes, t raised to the power of 3. Now let's see when v is equal to 0. Yes, let's see when v is equal to 0. When v is equal to 0 meter per second. Now remember our v here. Yes, this is our v. Our v is 4t. We have 4t minus 0.4t squared will be equal to 0. Yes, so at this point, here we have t. T is common, so let's factor out t. So we have t in bracket 4 minus 0.4t is equal to 0. So it means here we're taking this. We have 4 minus 0.4t is equal to 0. So 4 will be equal to 0.4t. So to get the value of t, our t, the value of t will be equal to, the value of t will be equal to 4 all over, that's just 4, all over 0.4. So here we have 0.4. So that will give us 40 all over. When you multiply this by 10, you have 4. Yes, what we actually did here, 4 times 10 divided by 0.4 times 10. This is like saying you're multiplying through by both numerator and denominator by 1. So 40 times 10 will give us 40, and 0.4 times 10 will give us 4. So that's how we actually got this 40 all over 4. So that will give us 10 seconds. Okay, now 10 seconds. So now what we're trying to say here, now at the peak, yes, we actually the flight actually got to the peak at time t is equal to 10 seconds. So now let's see, because the question here they say we should find the time and height. So we have gotten the value of our time to be 10 seconds. Now let's see the height. Our height, remember, recall s is equal to 2t squared minus 2 all over 15. We have t raised to the power of 3. Yes, so at time t is equal to 10, it means our x will be equal to 2 in bracket 10 squared minus 2 all over 15. Then here we have 10 raised to the power of 3. So here we have our x to be equal to, now this will be 2 in bracket 10 squared is 10 times 10, and that will give us 100 minus 2 all over 15. 10 raised to the power of 3 is 10 times 10 times 10, 3 places, and that will give us 1000. So here we have 1000. So it therefore means that our x now will be equal to 200 minus, now 2 times 1000 is 2000 divided by 15. So our x now will be equal to 200 minus, now let's look at the value of 2000 divided by 15. Please permit me to use my calculator at this time. So here we have 2000, okay, 2000 divided by 15. So that will give us 133.33. Okay, so now minus 200, that will give us 66.67. And of course, we know the unit for measuring height is meters. Yes, so that is the height. So now the question is find the time and height at the peak of the flight. So the time is 10 seconds, and of course the height is 66.67 meters. Okay, so now let's move straight to the next question. Now the next question is find the time when the drone returned to the ground. Yes, find the time when the drone actually returns to the ground. Okay, so now it means that here, when the drone returns to the ground, now the drone actually took off. Now coming down, it means our x will be equal to 0. Now remember, at the maximum here, we actually had 66.67 meters at time 10 seconds. Now returning to the ground, yes, our x will be equal to 0. Yes, no height. It will be equal to 0. So it means the drone returns to the ground, the total distance traveled. Okay, so at when the drone, let me call it when the drone returns to the ground, when the drone returns to the ground, comma, s is equal to 0 meters. X is equal to 0 meters. And remember, we know the value of our x. We know the value of our x, that our x is equal to, we have 2t squared minus 2 all over 15 t raised to the power of 3. Yes. Now let's see the time. Yes, let's see the time when the drone returned to the ground. So at this point, we said x is equal to 0. So it means 2t squared minus 2 all over 15 t raised to the power of 3 will be equal to 0. Yes, so that's the time at which the drone actually returns to the ground. So here, t squared is common. So now we'll take t squared out. Here we have t squared out. So we left it 2 minus 2 all over 15. Then here we have t. Because out of this t power 3, we have t squared outside. So we have t left. Now it's equal to 0. So we are taking this because this is equal to 0. So here we have 2 minus 2 all over 15t is equal to 0. So at this point, when you collect like terms, it means here we have 2 will be equal to, when you take this minus to the other side, it becomes 2 all over 15t. Now let's multiply through by the LCM, which is 15. Now multiply through by 15. Yes, now we are multiplying through by 15. So when you multiply through by 15, it means here we get 2 times 15, that's 2 in bracket 15. Yes, 2 in bracket 15 is equal to, we have 2 all over 15, then times 15, then we have t. So this 15 will go with this 15. So here we have 30 is equal to 2t. So now to get the value of t, let's divide through by 2. So we have 30 all over 2 is equal to, here we have 2t divided by 2. So here this 2 will go with this 2, 2 will go with this 2. We'll be left with t is equal to 30 divided by 2 is 15. And the unit for measuring time is seconds. So it means the time is 15 seconds. Now remember what they asked. They say find the time when the drone returns to the ground and the total distance traveled up and down. The total distance traveled up and down. Now let's look at the total distance traveled. Total distance. Now total distance traveled. Yes, total distance traveled. Now let's look at it. Total distance traveled up and down. So now we're trying to get the total distance traveled up and down. Okay. Now let's look at this now. Now remember the time it takes to return to the ground is 15 seconds. So now we're looking at the total distance it travels up and down. Okay. Now the total distance traveled. Now remember this is the distance it takes to get to the peak. Yes. Yeah, this is the distance it takes to get to them. So up and down, we can just use this. Now we say total distance. Total distance will be equal to up. Distance up. Now let me call it S up plus S down. Okay? Yes, S up and S down. So it means the total distance, yes, total distance will be equal to, now we have S up. Now let's get the value of our S up. We have it here, 66.67. So here we have 66.67 meters plus S down. Now remember here the total time it takes to come to get to the returns to the ground is 15 seconds. Yes, 15 seconds. So at this point, let's look at the total distance traveled. So now let's look at the distance it takes to return to the ground. Okay. Now distance it takes to return to the ground will be xd will be equal to, now let's look at the equation that's for our s. So here we have 2 in brackets, we have the value of t, and the value of t this time, look at it here, that's 15. So we have 15 square, yes, minus 2 all over 15, then we have 15 raised to the power of 3. So it means x down, total distance here will be 2 in bracket 15 square is 225 minus 2 all over 15 times 15 raised to the power of 3. Okay, that's 3375. So it means SD will be equal to, here we have 450 minus this times 2, that's 3375 times 2 divided by 15. Okay, so here we have 450. So it therefore means that, now if you look at this now the total distance up and down here, we said the distance it takes to come to the ground here is equal to 0. So it's actually on the ground. And that's why here we actually said let the distance be equal to 0. So we can see here that is actually giving us 0 because it's on the ground. Now it means the total distance now, the total distance will just be up and down. So let's add, for that of going up, we got it at 66 point, we have 66.67, then plus coming down, yes, look at it, yes, from here up, then from the same height coming down, so it's 2 times this distance, so plus another 66.67. So it means the total distance now will be 66.67 times 2, and that will give us 133.34 meters. Yes, that's the total distance. That's the total distance, both up and down. Right here, we have up from here, up, down. So 2 times this one will give us the total distance, both up and down. Now the next question is, they said compute the average speed over the entire flight. Yes, compute the average speed over the entire flight. Now we have done question A. Yes, question 1, question 2, question 3, question 4. So here I'm going to allow you, I'm going to leave this for you for as an assignment to calculate for the average speed for the entire flight. Thank you so much for listening. Share with your friends, subscribe, like, and see you in the next class. Thank you and God bless you.